Hi, in this video, we're going to talk about Cisco access lists, and also we're going to complete a few labs to illustrate the concept. Now, we're going to download this package tracer file, and then also open this document. Let's talk about the document first, then we'll do the lab. It would be nice to also have this binary table that I created for you a few weeks ago to make it as a either inverse mask or subnet mask to help us understand the concept better. Okay. Now let's talk about this access list, this lab. The objective is to apply the standard. There are two types of access list, the standard and extended. The syntax is down below here. For standard, we have access list and the list number, and they both start with a permit or deny action in here. With standard, then you don't have any way of specifying a protocol, and you list the source address, and then there's a source, the WM, wildcard mask. And then for the extended, you have more information. You can tell them where the destination that you want to apply this access list, and what is the WM for the destination address. And there's an operator such as equal to port number like 23 or port number 443 or port 80, and if you want to log it. So we're going to have actually two activity here with another two similar one in the following pages. The first one activity is we're going to block the host 192.168.2.2, which is here. We're going to block it from access 192.168.0.0, the whole network. Okay, we're going to block it from access the subnet and using the standard access list. Now we're going to block it from accessing just the web and FTP services from a particular host using extended, because the extended access list, we have a chance of specifying what services are allowed or not allowed. So first one, we blocked this host access the whole network. Second one, we block only the web and FTP access to the web and FTP server in here. Now we're going to review the concept. And the reason why I say review is I have another video posted before this one is to discuss the WM, the wildcard mask. Now we're going to revisit that and serve as a review in a little bit more specific syntax for Cisco. Now, ACL can be applied per protocol, per interface, and per direction, meaning that you can have one protocol for IP, one protocol for IPX, which is no longer used anyways, or at least not popular. So each protocol you can have one ACL, and you can also apply it to the interface, either coming in or going out. So you can have one coming in, one going out. When I mention coming in or going out, you have to picture yourself sitting inside the Cisco device. It is not just for this ACL, it's for all the Cisco device. If you say coming in, meaning that you sit here and this is in with the keyword, say in. If you say out, then you're out this way. And if you say this interface, S0 out, that means here. S0 in, then it's coming that way. Okay, let's take care of that first. By default, it's a host, but we'll talk about that more. It zero means that it has to match. This is a review. When the mask is zero, it means that we have to match. It's a significant in order for the for this rule, this line of the ACL to apply. And the one in your wildcard mask, in your WM, means that, hey, it's a placeholder. It doesn't matter as long as you have a valid IP number, then it's okay. We already talked about that in a previous video, but we're going to visit it more later. Now let's look at some specific examples here. If I say 192.168.22 and with the wildcard mask of 0.0.0.0 in here, that means we will have to match everything in our ACL. So which means that this particular ACL, or this particular access list line, is going to apply to whoever packet coming in with the IP number matching with 192.168.2.2 only host. So we can replace this with the keyword host. This is serve as a review. And now this concept, 192.168.2.0, with the wildcard mask of 0.0.0.255, it's kind of like reverse with what we had before. But let me explain it to you. It's easier to explain it when we drew it like this, similar to what we have done in the previous video. 192.168.2.0. So you write down the IP like that, and the inverse, wildcard mask is 0.0.0.255. So we put it like this, and then we'll know that, hey, we have mentioned the WM can be any number. However, if it's a 0, that means all those are significant. In order for this rule to apply, the incoming packet to be exempt by this rule, they must have 192.168.2 in the first 3 bytes of the IP. The last byte here, we mentioned that if it's 1 in the WM, you must put a 0 there. So yeah, it complies to the rule. And what it means is, this is like a placeholder, and we don't have to match. It's insignificant. So for a rule to apply, we must match the significant parts of the number in the access list. And the one that's not significant, meaning that you can carry any IP. So that means the whole class C network is subject into, will be applied with this rule. So we look at it again. So it will apply to the access list 2, whatever the packet coming from 192.168.2, because we use this standard access list. So it's a source address. So the source, if it's coming from 192.168.2 network, and we use this subnet mask, that means that everything from this 192.168.2 network. So that means any host from here is subject into whatever the rule we say permit or deny. We go into a little more further detail. Let's say if we say like this, what would happen? Well, I don't know if you would do that, but mathematically, or go by the definition, it's like this: 192.168.2.1. So that's 192.168.2.1. And the WM mask is actually 0.0.0.254. So we put it in here, 0.0.0.254, just like we did with the IP subnet mask. But of course, they have different meaning and different rule. Now, this one was the WM. If the WM is 0, that means we have to match. This is significant. So yeah, for the packet coming in and to be a candidate to receive this rule, it must carry 192.168.2. And furthermore, it also has to match the last bit here. The last bit is 0. Therefore, this is also significant. So whatever packet coming in, we don't care about this 7-bit that you can have any number. But your first 24-bit must be 192.168.2. And your last bit must be a 1 in order to receive the permit or deny for this rule to apply to you. So if we take a look at So if we take a look at this page that we have seen, you will see that, okay, let me just move it, rearrange it a little bit. You see, we care only about the last bit. Now we are not going to look at the full 3-bit because it has to be 168.2. So we know we're only going to worry about the last byte, and in particularly the last bit. So we take a look at this last bit in here from this printout. Remember, there's a 0, 1, 2, 3, all the way to 255, and I convert it to binary here. So you take a look at it. The last bit is 1. Last bit is 1 here, 1, and then 0, and 1, and 0, and 1, and 0. So 0, 0, 0 is 0, and 1 is 1, and 2 is 0, and 3 is 1, 1. So it's like every odd number, 1, 3, 5, 7, 9. Okay, so it's all the odd number. If you look at those handout, those binary to decimal conversion, it makes it easier to picture the whole thing. And of course, once you picture it, you probably don't need a handout to get the idea. Now, for this one, if we change that into a 0 here, instead of 192.168.2.1 here, and we change that to 2.0 and use the same inverse mask, then of course, it's all the even number. Okay, this time, all the even number will be subject into this rule. Okay. Now we're going to look at this one using the class B to do it. This class B, then we are focusing on the 3rd byte. And the 3rd byte is 254, just like the 4th byte. So, same reason. We're talking about all the odd number of the 3rd byte. And we don't care about the 4th byte. Everything is okay. It will be subject to it. So as long as we carry 172.22, and then whatever the odd number here, then yes, you will be receiving this rule. So now this one is like the host. Okay, any host. It's just a repeat of what we have. We can do a show access list, which we'll do it in the lab, and show IP access list, which show you the same thing. Or you can show IP interface and a show run to build the access list for troubleshooting reason. And as we mentioned in the previous video. So now let's get familiar with this topology here. We have network 1, network 2, network 3, network 4, 4 network separated with 3 routers. And this router FA00 connected to 192.168.0 network. And this is the server, which is located at 192.168.0 network. Its IP is 111. And now this is 10.10.0 network here. And we use the S00, actually, I just abbreviated, okay. In the package tracer, I will put down more detail of the topology here. But you know that S0 is a DCE with the clock rate being set. And then to 2 million, and then connected to the DTE, and then S1, which is 10.10.02, which connected to S0. And again, as repeated, S0 connected to S1. And we have to add, of course, the T1 card into the router, which I'll show you later in the lab. So we will have this S0 connect to S1, S0 connect to S1, and this network is 10.10.0 network, and this network, of course, is 10.10.1 network. And the last network here on the right-hand side is connected with the fast Ethernet 00, and its IP is 2.1, and connected to the 2.2 host that we're going to test. And of course, our objective here for the lab is to use the standard access list to block the 2.2 on the right-hand side. The 2.2, we're going to block this one from accessing the whole network. All right, and then we'll use the standard extended access list to just block specific services. All right, now this before we go to the lab, there's one concept I have to mention it to you. If we are using the standard access list, Where are we going to apply it? See, you have two interfaces each. So we will have 2, 4, 6. 6 interfaces. Both direction, coming in, going out. So we have 12 choices. Are we going to apply it to the access list once we create it for the inbound in here or outbound there, or inbound here, outbound there, inbound, outbound, or outbound, inbound, and so on and so forth. So there is a logic there. For a standard access list, we only know the source. If we create an access list, say, all right, access list 10, we want to deny, right? Okay, we want to deny 192.168. We put down 192.168.2.2 here. Or you can say host, we deny the host, 192.168.2.2. Now, if we apply, we choose a place, and that's all we have to say in the standard access list. Say deny 192.168.2.2. So it will be denied. And it will be actually denied to go anywhere, not just the 192.168.2.2 or, or any destination or 192.168.0. anything, because 2.2 in here is the only source address we put in. So if we say deny, if we put it in here, well, you just denied it already. So even if it doesn't want to go to the 192.168.0, our purpose, it will be denied even if you want to ping 10.10.11, because you put it here as an inbound. Well, you wanted to apply inbound because this packet coming from here, it's coming in. So it's in the FA00. Deny that. And if you do that, if you're flying inbound here, say inbound is not a good idea, because sometimes we say inbound is from more less secure to go to more secure. There's completely nothing to do with that. Okay, inbound just means coming into the router. Outbound just saying that going out of the interface. So we'll use the inbound outbound for simplicity's sake. So if you apply here, you actually prematurely deny it from accessing any other network. We may as well just unplug the cable from this host. That's it. It cannot go out. All right, so since it doesn't have a place for you to specify destination, then we have to help it. We have to move it to the closest to the destination. Okay, so therefore, we don't accidentally or prematurely deny it. If we apply it in here, then it cannot reach 10.10.0. If we deny it here, we may as well unplug it, right? So we have to move it all the way to the closest to the FA00 here, outbound. We won't even allow it to come in. We just don't want to allow it to go out. And when it come in, it can ping. When you allow it to come in, it can actually ping to the 0.1, which we will test it. But you cannot ping through to the 1.1.1 here. And of course, you can, if this router has another route going out to other network, yeah, then you can go out. So we only blocked whatever can go out here. And if you don't want them to even be able to ping your router 192.168.0.1, then you can apply inbound here. But we just go by the convention that if it's a standard access list, you're going to apply to the interface that's connected to the destination and then outbound. So that's the rule number one. And the second one we're going to discuss is about extended access list, because you have not only the source. So in our, we can further complete the standard access list by saying, okay, I want to deny that 192.168.2.2. I want to deny it, but what I want to deny it is I just wanted to deny it, deny the FTP. I want to deny it the web, okay, and I want to allow all the rest. So protocol-wise, I can specify it later here. But I also want to specify the most important thing is the destination address. Now, instead of leave it blank and I don't know where to block it, I do know it's 192.168.0.111 I want to block. Okay, so when this 2.2 host, if you want to go out in the packet to go out, as I mentioned many times in class, it must have source IP, destination IP, source MAC, destination MAC, and also, the source transport layer, TCP or UDP, and the destination. So you already know what you want to do to go out. So the packet already say, hey, if I wanted to, the 2.2 want to go to the 0.111 web access, www, then the packet coming in already have the source, already have the destination, already have the port 80 here. So we already know this packet are not allowed. So instead of blocking it here, blocking it there, we may as well just block it right away here so that it wouldn't waste our bandwidth. So for extended access list, what we want to do is we want to apply it to the closest to the source because we already have all the information to decide if the packet is allowed or not allowed. We already can make a decision right here. Why bother and let it take up our bandwidth and deny it later? Okay, just a review. Standard access list, because we do not know the destination, so we have to help it instead of prematurely shut it down earlier so that the host cannot go to other network. We have to put it to the closest to the destination outbound the interface. For the extended access list, because we know both the source and destination and know what allowed, what not allowed to do as the port wise. FTP, if 192.2 want FTP to 10.10.11, well, we already know that it's supposed to be able to pass. So we just go ahead and apply it here and let it pass. And if 192.168 to FTP to 192.168 0.111, we already know that, hey, it's supposed to be denied. Then we may as well just shut it down here. So for extended access list, we will apply it to preserve the bandwidth to the connection that's connected to the source and the inbound, the in. If you connect out, it will not work. Okay, this we have to connect in, and this one will connect out. Okay, so the direction does matter. Okay, all that being said, we are going to do the lab. So number one, we're going to download this document and the lab.pk from the canvas, which is already there. And then we're going to enable, it's already did, I already enabled the FTP and web in your PKT file. That's pretty straightforward. You can also enable it too. So this will be 192.168.0.111 and the host with the IP address and the default gateway. And I already put it in there for you, so I can save some time. And we already went through this many times. That's why I just go ahead and save it as default to save you some effort. To test the FTP, you are going to enter admin and password is changeable. Okay, so if you want to test that. So now we are going to review and copy the syntax to the packet tracer device. First, let's review it. The first one, let me bring up the document. So when you download it, this is the topology you're going to see. And you can see that this is A router, B router, and C router. And exactly the same as the document, except that it says S0, S1, and S0, S1. Okay, so depends on what we have put in there. You will have different the serial interface and the port number. So first we go to the CIS57A router here, and interface FA00. That's 00, and we give it an IP address and no shot. Automatic speed, automatic break, that's pretty standard that we already know. Now we already put in a T1 car in here, so then you will have a serial 1, and you will have serial 0. So let's take a look at another router here. Let's say we added another. Let's say we move another router here, we add it here, and then we take a look at it, and you can see, oh, I have so many choices. And we have a WIC2T card, okay? And we can drag it into here. Whoops. When the power is on, you cannot do it. So we have to kind of click it off, right? So we move it in, and we put it in, and whoop. After that, you have to power it on. So then we just added the serial card in there. So we're going to put it on the side for now. Oh, it's already done. So we're going to say no. Always say no for this question, right? But it's a good checkpoint, so we know that it's not been configured. Enable, right? Show run. And now if you take a look at it, you can fast Ethernet. Yeah, sure. Now you see, you have the interface now. So if you do the show run first before you add a card, you're not going to see the serial port. Okay, it's nothing. If you do your own topology, you drag it in, you wouldn't see any serial port. So you have to add a module into the Cisco box. And this is for the frame relay T1 line. Very popular, used to do that for quite a few of my clients. Okay, so we don't need this anymore. We are going to go back to our original discussion of the syntax. So now you go to the serial port and you can say, hey, it's a PPP, or you can do a HDLC. But PPP is popular and easy, so they're both easy, just one line. But you have to match. So if you do PPP here, you have to do a PPP there, as we have mentioned before. So encapsulation is PPP, so you're doing a layer 2 using a PPP and using this IP address to communicate. So there's a layer 2 connection in here. And clock rate, 2 million, or you can set it higher. It's not a real production network. I just go and choose any number. And now, one is your DCE, so you actually create clock rate. And when you select the cable, now it will tell you that there's one of them is a DCE and one of them is DTE. So here is a DCE and here's the DTE, okay? So you, if you choose the DCE here, you click here, it will become DCE. And you have to give it a clock rate. So it's kind of like older technology in a way, because the DSL, they don't use that anymore, and DSL is almost taking over all the internet installations here. And of course, cable, yeah. So frame relay is popular. Some area they don't have those phone lines, and frame relay is the first one that's available. That's why the frame relay has a cloud symbol. It's like used to be like internet symbol. All right, so then we set this one. 01 in here is not being used, so we just keep it shut down. Don't do anything. We are not going to configure static route. We just go ahead and enable RIP. So hey, RIP is fine. And we are going to do network 10.10.10, so all the 10.10.10, it will talk themselves out and know how to forward packet. And they also connected to 168.0 here, so you have to put it in here. Okay, let's continue on to the second one. Very similar. Config key, give it a host name. Interface, I think I give host name there too, right? Yeah, config key host name. So config T host name interface S0. S0 is DTE, so you don't have to config. No, S0, I put it here. S0 always DCE. So in my convention, S0 is DCE, S1 is S01 is the DTE. So 01 you don't configure clock rate. S0 you do configure clock rate. Okay. And on router RIP 10.0.0. And router C, same thing. So it's pretty straightforward, but in here, you have to watch out. That is the one, okay? That is the one we need to give it an IP address of that. And it's PPP, no shot. Router RIP, and you put down those two in there. Okay, so what we'll do is we'll copy and paste it in. CLI, hit enter, and you're going to say enable. Let's do a show run. Make sure there's nothing in there. probably has something already saved, but it wouldn't matter because it's nothing really conflicting. You can do a write erase if you don't like to see it like this. You can do, just want to make sure, you can do a write erase and reboot. So it will be clean. Let's see. I'm going to move this document to the side now and put the packet tracer as our main focus, right? Okay. We're going to configure this box. So when you highlight and copy, make sure you don't cross the page line, okay? So in here, I try to make it in one single page. In here, this is a router, right? Do not copy over this one because there are some of those line breaker in between, page breaker in between. It might mess your copy paste in. All right, right clicked and paste it. So make sure that we read it. There's nothing funny here. Well, this one is redundant, so you should clean it up. I think I already cleaned it up, but probably not. So I'm going to delete that one. So we don't need this. So some syntax that I actually use, it doesn't work in certain model. Okay, I'm going to fix that later. So if you see error in here, it doesn't actually affect our exercise. Okay. Now we are going to do the router B. So router B, we're going to do here. So router B only configure 2 of those serial interface. The fast Ethernet, okay, not being used. All right. CLI. Click here, hit enter. All right, enable and paste. Let's see if there's an error. Okay, no error, as you can see. Now we're going to look at router C. And CLI, hit enter. Enable. All right. May as well make it big. And I'm going to just highlight router C's configuration. Copy. Paste. Okay. No error. It comes up, lines up. That's all right. So let's take a look at it. It's going to, oh, okay, good. It turns all green now. So let me just take this one off. So first thing first, let's see. Let's go back to the document. So after we copy everything in, now we're going to do this. You copy the syntax to the router, and now we're going to configure the standard access list to do the exercise. But before we do that, let's make sure everything works before we start our exercise. We are going to, on number 1, we are going to block. If you take a look at access list, if to deny it, deny that one. We just say deny the host, and we didn't say the destination, even though our job is to deny it to the 192.168.0, but we didn't know. Therefore, we have to apply this one into the router A. So copy. So that's why we say copy the syntax to router A. And to avoid prematurely block the packet, apply the list to -A router FA00. Okay, so that's how you apply it to FA00. And then the keyword is called access group. So you define access list, say deny this guy. Or you can say deny host that. Or you can say deny 192.168.2.2 with 0000 here. Okay, and then you have a permit. You can say permit any, or you can say permit, nothing matters. Remember, all the ones in the wildcard mask, you have to put a 0 in the IP, and it means nothing is significant. Therefore, this is like permit any. So you deny one and you permit any. You only want to deny that. Very importantly, in the access list, you must have a permit there. Otherwise, if you only deny, and Cisco has an implied deny at the end, as we mentioned in the previous video, you may as well unplug the whole the whole interface out. Nothing can pass this access list. Okay. All right, so access list is pretty straightforward here. The location, we already know where to apply. And then this is the way to apply is to say, use the keyword called access group 10 out. You are already in the interface. So you're in the FA00 and you use access list 10 outbound. So at FA00, you're already in here, outbound. That's exactly what we want to do. And to remove it, because we have to continue doing the work, and we cannot have this access list interfere with our exercise. So you have to go config T again, say no access list, take the access list off, go back to the interface FA00 where it's in apply, and we're going to say no IP access group 10 out. So negate of what we did. So you just copy, after you tested it out, make sure you copy those 4 lines and paste it back in to set the router back to before we apply any access list. Otherwise, all your exercise will be messed up. Now, before we test it, we better make sure those 2 can work. So I'm going to put it on the side. We can ping from here first. Go to the desktop, and we can actually do an IP config. You can say, oh, okay, I already put in a default gateway for you, and that's all you need. Ping 192.168.0.1. Why not? Good, it's working. And we're going to ping the server at 111, and it's supposed to work as well. So we go from here, ping through all of the routers, and then we can ping all the way here. We can ping that too. So this network is accessible. Okay. And if we would do FTP, let's take a look at the FTP. So if you look at the services here, and you can take a look at the HTTP. It's already been turned on. Okay. So then let's take a look at FTP here. You see, admin change me has already been put it in. You can actually type in yourself. You can say, hey, my name is Jack, and password is I'm here, and you can give it rewrite, and then just don't forget to click add. Okay. And so this is the way you create it, or you can use Cisco. So that is the preliminary thing we need to do in order for the exercise to do. The topology is pretty blank. All I did is just drag those router in and drag the interface in, and then connect DCE to DTE, DCE to DTE. And then this cable, this router is a little bit older, so you have to use the crossover cable. If it fails, just click the magic one and let it go, find it for you. And all the rest, this one is straightforward, straight through cable. Okay. And I just happen to choose a few different router to do the exercise. So now we are going to test that out. We're going to go to this router, and we're going to apply it. Actually, config T in the front will take care of that. So I'm copying those 4 lines, just let you see it. I'm copying those 4 lines to deny the box and put it to the closest to the destination, of course. And after I did that, I didn't do FTP, but you see, now the ping failed because of that. And if you want to put the sniffer here, you can see, you know, it went through, but then it cannot come through. No, we're not going to do that. And if you do FTP, then it will work. It will fail also. And by the way, since we are at this topic, we may as well just show you, exit it out, and you can do a show. You can just tag ACC access list. And you can see that, oh, you already got denied 4 times because you pinged me 4 times. And if I go FTP in here, if I FTP to 192.168.0.111, oops, then try to connect here. And we just do an up arrow key again to see it. And you can see, oh, okay, now you have 16 match of this line. So when the packet coming in, the packet carrying the source IP address 192.168.2.2, and the access list say, deny that. So therefore you match, so you got denied. You can't FTP in either, or you cannot ping either, okay? So Control C to break it out. So now your ping 01 still work because it's not going out. So the access list really didn't matter, it didn't change it at all. Okay. So you can see that when you ping to the interface here, it didn't go out. So the access list is not even evaluating it. Okay. Now we need to negate it. So we are going to come here so we can continue on with our exercise. When we negate it, you're going to go here, right click and copy here and paste. Okay, it's always nice to test that out. So we come in here again, up arrow key 2 times, the ping, oops, it's FTP. Sure, I can do ADMIN, change me, CHANGEME. Good, passive one, we're already in there. So quit, and we can also ping it. So the ping doesn't work. So that means we already successfully negated it. Everything is back to square one, the original stage. All right, now we're going to move on to the second activity, which is using the extended access list here. So extended access list, take a look at it. Deny TCP for this host to the destination, the www and the FTP. So I'm going to deny those two, or else permit in here. And I'm going to apply it to the closest to the source. So applied it to the C router, so to save the bandwidth. You can see that. We wanted to do it here. This is the host. And we already know if it wanted to FTP and web access here, we should deny it. May as well deny it here. Why deny it here or here or here or here and waste all the traveling? All right, so we are going to apply that one. So this syntax is pretty much straightforward, about the same as the previous one. And I think it's also reasonable to see this syntax here. It says deny TCP source host. Instead of saying 192.168.2.2, 0.0.0.0 is much easier to read by seeing the keyword host. Except that you move the 0.0.0.0. You didn't say 192.168.2.2 host. You say host in the front of the IP, okay? So you deny source 2.2 to destination 1.1.1. And what protocol do you deny it? This and that. And the rest, there you go. Very straightforward. And then we apply it to the closest to the host, the source. So copy, and we are going to go to the C router. I'm going to move this away, and it's come here. Enable. All right. Paste. No error. Well, and we already tested in here. We already tested that everything works fine here. You can ping, you can do everything, and then you say, okay, ping. Hey, still worked. What's wrong? Nothing wrong, actually. Let's take a look. If you want to troubleshoot, if you didn't know what's wrong with it, exit it out, and let's do a show access test. Let's make it bigger. Hey, you see your packet coming in to ping. It doesn't match. It match source, match destination, doesn't match the protocol. So go to the next line. Are you trying to do FTP? No. Are you trying to ping? I don't care, because permit IP any. So you will ping. Have 4 match here. If you ping again, it becomes a match. All right. So that's a nice troubleshooting. So we do FTP again to see if our it's not connecting anymore. So let's go to here one more time to show it. Now you can see now FTP, you have the match. And if you do www, it will see something in there too. Okay. So I'm going to skip that www. So here with a ping from that still works, but FTP and web will fail. Explain why, you know it. And also you enter the show access list to see the matches of each line, okay? Now we need to negate it, otherwise it will interfere. Say no access list and go to interface and yank it out. Copy, come in here, and let's paste it. So it's gone. And always a good idea to test it and don't take it for granted. So let me go FTP, good. Once I see the username, I know it's asking me, I'm getting a green light. So I'm not gonna worry about that. Now we're gonna continue on with the exercise. The one that's not listed previously. So I just think that I added a few more, 2 more here. Now we're gonna deny 1010 x1 and denied it to, we're going to deny this to access the host. So the direction has been changed a little bit in here. We're going to deny 1010, whatever in the middle. Okay, the third byte is insignificant. And I wanted to see the dot 1. So first byte, second byte, 1010, last byte, 1. Here, 1010, 1. 2 doesn't matter, 1010. Third byte doesn't matter, 1. So I want to deny this box and that box from accessing this for some reason. This is just for mathematical reason, and I guess more than the real usage. I have some network administrators say, hey, all the odd number can go out the internet, or the even number cannot do this. That's a little bit stretching. Okay. So access list is very important, but sometimes this way, this welcome as it makes it mathematically so powerful. But I would rather if Cisco can actually change that to be the same as the firewall's ACL, that is using regular subnet mask and define the traffic. That's more straightforward instead of this WM method, which is more mathematically superior, but harder to understand, and we really don't need that kind of mathematical function to configure our network. All right, so we are going to just deny that. So we can say deny 10, 10, 0, 1, 0, 0, 2, 5, 5, 0. That means, hey, the third byte, this one is insignificant, meaning that, hey, when it's 1 here, it has to be 0. And it means it's just a placeholder, insignificant. So whatever comes in with 10, 10, and the last byte 1, denied it. So we will test it with this one and with that one after we finish it off. So what we will do is, then of course, this is an extended, this is an extended list in there. So we want to set it to closest to the sender. Of course, you can send it here. You can set it here, but I think set it here probably is more effective. So I ask you to apply it to router B, or actually we can apply it to router C, because sometimes in some Cisco devices, when it goes out from an interface here, as long as it's from the direct interface here, it wouldn't check on that against the ACL. Okay, so what we will do here is we are going to make sure we apply it to the router C. We're going to apply to router C S031 in here, which is S031 in here. because if you apply in here, Cisco, this one was, it's their router design that when it goes out, it wouldn't actually check against that ACL. It's supposed to, but it doesn't in these simulations. So let's just follow along with it. So you're going to apply it. Here is the closest to the source. Okay, so this is considered as a source, and we don't let the source do the work. So you have to watch out and using the C router here and for the inbound. So this is why the syntax like this. So we are going to go to the inbound. Copy. We go in here. I think it will work if we just do that. Yeah, config T, and then just go and paste it in. So once you paste it in, then you try here, and in 192.168.2.2. We have to exit, right? 192.168.2.2. Well, it's unavailable now, right? So that means it failed. And how do we see it? You can do show. So you can see that you have 5 match of the deny. And if we go from here, then of course, enable pin 192.168.2.2 and also fail. So if we do that again, oh, they got 10 match. Well, I think something got sneaked in here. So in any case, we will. So I was curious what has come into the sneak into the network, because if you do the show access list, you did see that 5 packet got denied, and then you did got 1 sneaking in. So you can add a sniffer here and then just connect it. Then you can actually leave it to show all of them, and it find out to be the RIP coming in. So of course we did deny RIP, right? So therefore, when you ping, you get denied 5 times there. And then 1 pass through is the RIP. RIP is the router communications. And we did deny it. Of course, it hit the line. And it will keep growing, I guess. So if we keep doing that, and we'll take a look at that again. And you can see, oh, yeah. It's not just associated with the ping. It's actually the RIP communications. So that's solve our question. And if you want to see how it's been done, it's pretty straightforward with this sniffer. You just click there, and I know, and I can actually take this off, take that off, right? So now sniffer, I may as well take it off. So we are going to click in here. Yeah, click on the second one, and you see the sniffer here, and you just put a sniffer here, and then we'll connect the router. Connect the line. That's Ethernet now goes here, Ethernet 0, and then we'll connect Ethernet 1 and go to that's Ethernet and go here. There isn't much to configure, but you probably want to clear it first. And then if we decided to do ICMP, or you just wait a little bit, it will show that. 168. Oh, we cannot ping this one, huh? We have to use the router because we were testing it with that. The 192.168.0.111, it will work. This one, it will fail. And you can tell that, oh, you got 1 RIP already coming in. Of course, ICMP is not going to come in. But if I do here, that 2.2, if I do that, we can take a look at the sniffer. Then RIP coming in, ICMP actually comes through. You see that? You push up and then you find it. And if you go to your share, then of course, then you will see you have more matches here. And of course, you can clear it in a document. So if you want to see it, you can actually do let's pick it easier. Clear. Okay. Show access list. Oh, now we have nothing in there. So then you can restart your exercise, and you can actually monitor it or do your troubleshooting. Okay, so this concluded our discussion for the access list with the welcome mask, and also with some example in the lab and some troubleshooting for applying those access lists.